Mr. Vijay Raina, who is the Assistant National Sales Manager for the Absorption Chiller Division of Bry-Air and has over 20 years of experience in the heat division chiller technologies for energy saving and environment conservation for cooling applications. Vijay is a B.Tech chemical with a specialization in energy and environmental studies from Pune University and is currently based out of Gurugram. Today, Mr. Vijay will walk us through green cooling using hot water, that is waste energy. So delegates, let's welcome Mr. Vijay.
As my introduction gave Ms. Rajeshwari, so I'm talking about adsorption chillers today from product point of view, that how we will save energy and environment for comfort cooling as well as for industrial cooling application. What is adsorption chiller and comparison, and then second, technology, how does adsorption chiller work? This second point will take more time since we have a time limitation. I will go through the same very fast and hope you will understand basic technology today, and then later on we can discuss. And then we are talking about the low grade waste heat source. We are not talking about the high grade heat source for adsorption chiller technologies. Definitely silent features of adsorption chiller, working list of adsorption chiller projects, what we have achieved from last 5 years in India, since it's a new technology, new introduction, green technology in India by Bry-Air, Make in India technology. Adsorption chiller product range which we have right now in our company. What is adsorption chiller? It is nothing but we use hot water as an inlet and we generate chilled water with some temperature range. Minimum is 5 degree and maximum can go up to 20 degrees centigrade by using hot water, which is a low grade waste heat available from any industry. It's not a magic, it is a advanced green technology. We use silica gel as an adsorbent and water as a refrigerant, as a natural refrigerant in this technology. Everybody knows that refrigerant takes the outside cooling load and throws through the condenser. So this refrigerant is moving from one heat exchanger to another exchanger in a closed loop with the help of the compressor. Compressor is the heart of mechanical chiller, whether it is screw, centrifugal, scroll, whatever technology is available as on date. Our technology is now to replace this compressor where huge energy is consumed by using silica gel, and the purpose of silica gel is same what compressor is doing, transferring refrigerant from one heat exchanger to another. The same way we are transferring our refrigerant from evaporator and through silica gel, and finally it goes into the cooling water side and the heat gets dumped in the outside in the cooling tower. So in our technology it is always water cooled technology, it is not an air cooled technology, so we always need a cooling tower on condenser side. So you can see the comparison between the two technologies there. We don't need any compressor, so there is no electrical consumption for our technology. It is nothing but it is thermally driven, and we use silica gel to transfer energy from outside through our refrigerant water. This is the basic construction of our adsorption chiller. There are three chambers. On below of the chiller you see the evaporation chamber. On top it is a condenser chamber, and in between there is a silica gel filled in chamber 1 and chamber 2, which helps us to transfer the heat from refrigerant evaporator to condenser, and then again same refrigerant is coming back in the evaporation section to achieve the chilled water desired for the cooling application. Like for example, we are getting 12 degree from HU or from the process cool heat exchanger, and we are giving continuously 7 degree. When this process is happening, our evaporation chamber is already filled with the refrigerant water, and then this refrigerant water gets evaporated with the help of vacuum. Because this is a vacuum based chiller, we create a vacuum for water to evaporate at a very low boiling point. So when we maintain a vacuum in a closed vessel, it's a simple chemistry that water boils at low boiling point. The boiling point of water is only 6 degree at 10 to 15 mm of mercury pressure. At atmosphere pressure, it boils at 100 degrees centigrade, and during vacuum, it boils at 6 degrees centigrade. So in evaporation chamber, we have a refrigerant water filled initially with the chiller, and then we take a load from HU at 12 degree. The refrigerant water at 6 degree boiling point, it gets evaporated. Once it gets evaporated, so we have to transfer this refrigerant vapor from evaporation chamber to condenser, and we are doing this through silica gel based technology, where silica gel is nothing, it's a solid material which absorbs the water vapors on its surface. So you see the 29 degrees is a cooling tower water. When the cooling tower enters in chamber 1, it is a cold chamber, pressure is low. In evaporation chamber, evaporation is happening, it's getting hot and pressure is increasing. When pressure increases, water will what refrigerant water will flow from high pressure to low pressure through this flapper wall. There are 4 flapper walls which separates the chambers, and these are nothing. These are only pressure dampers, pressure relief wall, pressure dampers. Nothing electro or mechanical involved in this. So no electricity is consumed in this chiller. It's a natural refrigerant is moving from evaporation chamber to at the silica gel chamber 1. And we are giving 2 utilities, one cooling tower to keep it chamber cold so that there is a proper adsorption happening in the chamber 1. At the same time, we are giving a heat. Now, hot water plays a very important role in this. So, when we get a hot water at 90 degree or 70, 60, minimum limit is 60, maximum is 90, 95. We can use in this technology as a hot water. So when adsorption is happening in chamber 1, in chamber 2, we give hot water to make it, we regenerate it to make it ready for another 5 minutes, because this is a cyclic process. We cannot use only single bed to transfer the refrigerant water from evaporator to condenser and back into the evaporator. So we use 2 chambers separately, which are cold chamber and hot chamber. Hot chamber definitely pressure is high, so this flapper is closed. This cold chamber pressure is low. This is a hot chamber evaporator. This flapper is on. Every 5 minutes, these diagonally flapper walls will be on to transfer the entire refrigerant from evaporator to condenser. Now, when we are giving heat in the adsorption chamber, whatever refrigerant was adsorbed by the silica gel in 5 minute cycle, then it get released with the help of hot water. So we called it as a cooling and heating chambers. Cooling chamber 1 and hot chamber 2. But ultimately, our job is to transfer refrigerant water from evaporator to condenser. The same refrigerant is reaching condenser, and then in condenser we give the cooling tower water. Here, as compared to conventional mechanical chillers, we use more cooling tower heat, because cooling tower has to move in 2 heat exchangers, adsorption chamber 1 and adsorption chamber and condenser chamber. And with additional to the chilled water heat load, we are giving heat load as hot water. So there are 2 heat loads on the cooling tower. So heat load dissipation is more in our cooling in our adsorption chiller as compared to conventional chillers. So when refrigerant water is reaching to the condenser, we need the same refrigerant. So you see only 2 flapper walls are on. So refrigerant is moving like this in adsorption chamber 1. At the same time, refrigerant which was earlier absorbed by the chamber 2 is released and reached to the condenser chamber. The same refrigerant water now is used in the evaporation chamber. So it comes with the gravity flow, and we circulate the refrigerant in the entire evaporation chamber. This evaporation chamber is nothing, it's a simple shell and tube heat exchanger like in our conventional chillers. Condenser is again simply heat exchanger as conventional mechanical chillers. Only the portion middle chamber, adsorption chamber 1, adsorption chamber 2 is replaced. We have replaced the compressor with the silica gel technology. The silica gel works in a cyclic cooling and heating mode, where we use one cooling tower water and another regeneration hot water. So after 5 minutes, there will be a change in the cycle, and there will be a change in the flow of cooling water and hot water, because when adsorption chamber is absorbing the water vapor refrigerant, it becomes saturated in 7 minutes or 6 minutes. So we have to make now adsorption chamber with hot and regenerated, so that it releases the whatever it has absorbed in the first cycle. So there is a mass transfer happening in the chamber 1 and chamber 2, and cooling water is now from chamber 2 to condenser on top of that. So see, these 2 diagonal flappers are on. A simple construction chiller. There is no outside going inside the chiller. It's complete single shell chiller, and single shell is maintained under vacuum, and refrigerant is moving from one heat exchanger to another exchanger through silica gel technology. So this was the cyclic basic how it works and how we transfer the heat from chilled water to refrigerant water. Then refrigerant water, how it moves from evaporation chamber to condenser, giving heat to the cooling tower and coming back as a pure liquid refrigerant in the evaporation chamber to complete the chilled water cycle. So finally, the finished product is like this. How this is a middle chamber. On below it's an evaporator. On top we have a condenser. Then we have a HMI control panel system, and then we have a vacuum pump chamber here. where we install the vacuum pump initially required for maintaining the vacuum at the time of commissioning. After that, it is an intermittent working of that. So outside vacuum, you see the header. This header is nothing but this is a cooling water and hot water changeover, which is happening every 7 minutes in this technology. In order to get a continuous chilled water temperature here on below of the chiller, so we use this cyclic time through HMI, and there is a changeover through 10 to 12 butterfly valves. These butterfly valves are nothing but they are pneumatically activated butterfly valves, which gives the direction for cooling water changeover and hot water changeover between the chambers. And this is the finished product, factory tested product for chilled water generation based on low temperature hot water, which ranges from 60 degree to 90 degree. So low grade heat source available across the industries. Every power generation plants have exhaust available. Solar thermal is for commercial application, and if it is a small CHP application for commercial buildings, we can also use that heat in our adsorption chiller. Food processing, we have own exhaust gas engine, DG sets, jacket water we can use as a low temperature hot water. Then we have furnaces where exhaust gases are available. Process heating is directly available through exothermic reaction in various industries. Then automobile industries or any food industry, pharma, every general industry have screw air compressors. That air compressors we can use as a heat driving source because they have already the waste heat available in the compressors. Since we can also use, now we are working on one development of this screw or ammonia chiller condenser cooling. Wherever the hot water is available from superheater on condenser side, that temperature generally goes 55 to 60 degrees centigrade. That 60 we can easily use in our adsorption chiller, and we can generate chilled water for customers instead of using this into the heating application for washing, cleaning and all that. So this is another energy saving for the customer from the existing screw chillers or ammonia chillers. Like in like in air compressor, pneumatic air compressor, we have this waste heat potential available. Adsorption chiller, everybody knows that we don't use the HFC refrigerants, and our chiller consumes only 1% of electricity. If it is a 100 TR screw chiller, which consumes normally 70 kilowatt of power, our 100 TR adsorption will consume only 0.6 kilowatt of power. Rest it will be run by hot water. Yes, definitely we need a pumping power for hot water that we can evaluate as per the hot water energy available with the customers. Then in our technology, we don't have any crystallization, no corrosion, and no replacement of desiccant for 25 years since it is sealed, hermetically sealed chiller. And silica gel is once filled in the chiller, and then we don't need to open the chiller for any top up or for any analysis of desiccant. Negligible maintenance, like we use green refrigerant water and desiccant silica gel. Hot water range is 60 to 95. We can use 60 degree for chilled water generation for cooling. There is no noise and vibration since there are no compressor, no pumps installed on the adsorption chiller, so we don't have any noise and vibration issues. This is a continuous operation with changeover from cooling and heating chamber in middle chamber, but on the below of the chiller we generate the chilled water continuously. Startup time is only 5 to 7 minutes, and chilled water temperature range 5 degree to 20 degree. Cooling water temperature we can use 15 to 35 degree as an inlet. This can be used for industrial and commercial application. So these are the chillers we manufactured in India. It's a 100% make in India product, and we have our test bench available in India, and we manufacture this exclusively as per our design available with us in India. So we started with IIT Delhi, and we have now 18 projects in hand. Out of 18, we have already supplied 15 chillers. Now 16 number, 17 number, 18 is under production, and we have already supplied rest of the chillers to our customers. Adsorption chiller product range, what we have right now, we have minimum 3 TR and maximum 330 TR as a single chiller available with us. We have this 330 TR factory testing available with us. We can test a single chiller for 330 TR cooling capacity. The smaller one is 3 TR, which is a canopy and covered. So this can be used anywhere in the application for cooling. Then we have 35 TR also. Then we have 75 TR also manufactured already for that. The smaller one can be stacked for 50 kilowatt, 100 kilowatt, depends on the heat load available at site. For commercial application, mainly we dependent on the solar or any other heat source available from CHP system. So frankly, for commercial, if you look after the solar renewable cooling solution, then we can stack it as 50 kilowatt up to 100 kilowatt also. Thank you.